Hello, hello. What you do? Join the just hold it in my hand. Hello. Okay. Let me see. Even other children, we come. Are we the same? How did the fools came? Hello, hello. Oh, yeah. Okay. So we started. And so we're going to begin with study questions on study practice questions, starting from functions. Okay. Yeah. Okay. So starting with the questions that we have. Question 1. So the function is given by f of x equal to 24. I ask to find the domain and the range of the function. So what do you think the answer is? That's based on the previous videos. It's not responsive. Okay, so let's start. They said the function is given by f of x equal to 24, and then ask for domain and range. So you've watched the video, that's my video on introduction to function. You said that if we consider the function f of x equal to k, where k is a constant, k can be any number. I explained that if this is a line representing f of x equal to k, what happens? For all values of x from negative infinity to positive infinity, the output is going to be k. So in this case, you're having 24. So for all values from negative infinity to positive infinity, the output will be what? 24. I remember the meaning of domain. Domain means the set of values, right, that a function can take and still exist. And then in the case of the range, we are talking about the set of possible outputs. And in this case, that output is 24. Because for all values of x from negative infinity to positive infinity, which is the domain, the output is going to be what? 24, which is the range, set of possible outputs. So the correct answer is option B. Do you also ask your questions? Let's take the next question since there is no issue. So the second question says f of x equal to the signum of x plus 4 plus the heaviside of 6 minus the absolute of x divided by the greatest integer value function of x minus 1 minus 4. I asked for the value of f of negative 0.5. So first of all, we have to understand the signum function, right, represented by SGN. You should know that if the input is greater than 0, the output is going to be 1. If the input is 0, the output is going to be 0, and then if the input is less than 0, the output is going to be negative 1. So starting with the numerator, we have signum of x plus 4 plus the heavy side of 6 minus the absolute of x. So all you simply need to do is anywhere you have x, substitute negative 0.5, and that will be the signum of negative 0.5 plus 4, and then plus the heavy side of 6 minus the absolute of negative 0.5. So do you remember the Heaviside function? So that the Heaviside function is just like the signum function, right? It's just like the signum function. The only difference is that if it's greater than 0, the output is going to be 1, just like signum. But if it's less than 0, it's going to be 0. If it's equal to 0, it's still going to be equal to 0, right? So if you simplify negative 0.5 plus 4, we're going to have signum of 2.5. 3.5, yeah, and then plus the heavy side of 6 minus. Then this is an absolute value function when you have two vertical lines placed within a function. So the absolute of negative 0.5 is going to be 0.5 because it's going to change the negative to positive, right? And then this is, if we should simplify this part, it's the heavy side of 4.5. And then since 3.5 is greater than 0, the signum of 3.5 is 1, right? And then since 4.5 is greater than 0, the heavy side is going to be 1. And then looking at the denominator, what we have is the greatest integer value of x minus 1 minus 4. So if we should substitute negative 0.5 into the greatest integer value function, over here, what we'll have is that's absolute greatest integer value of x minus 1 minus 4, and that will be negative 0.5 minus 1 minus 4, right? And that will be absolute. That's greatest integer value function of negative 1.5 minus 4. I know what the greatest integer value function does. The greatest input is the greatest integer that is less than or equal to that input. And in the case of negative 1.5, the greatest integer that is less than or equal to negative 1.5. Since negative 1.5 is not an integer, so you choose the next integer. If we should draw a number line, right? Here is 0, here is negative 1, here is what, negative 2. Negative 1.5 will be around this region, right? So negative 2 is the greatest integer that is less than it. So the output of this greatest integer value function is what? Minus 2, and then minus 4. So what we have on numerator is 1 plus 1, 2, and then all over negative 2, negative 4 is negative 6, and then 2 into itself 1, 2 into 6, 3. If you have any questions, please put it over in the comment section. Right? Okay, let's move over to the next. If you have any questions as concern what I just explained now, post it. Any questions? Maybe how the substitution was made or stuff like that. Okay. So let's move to the next question. The third question says f of x is equal to 6x cubed negative 8x squared plus 9x negative 4 over the absolute of x plus 3. And we have to find the domain of f. Right? If you watched my videos, you know that we discussed rational function, and we said that in order to determine the domain of a rational function, we already have the ideology that first of all, the denominator should not be equal to 0. So we can now use that as an advantage to get the set of values that the function can take, which is equivalent to the domain. So what you simply need to do is to equate the denominator, which is absolute of x plus 3, equate it to 0. Are you following? And then what I'm going to have is what? Absolute of x plus 3 We're going to have x plus 3 equal to 0. And then moving x over to this side, what we're going to have is what? X is equal to negative 3. This is the only solution. Even though we now, because you know that the absolute value function, what it does is that if the input is positive, right, it's going to give you a positive output. And if it's negative, it's not going to change it to positive. So even though what was in here was negative x plus 3, because it's possible, which is still equal to the absolute of x plus 3, right? And then if we have negative x plus 3 equal to 0, dividing through by 0, we are still going to have the same thing, right? So the simple answer to this is all real except what? Negative 3. That means all real numbers. It's just this denominator that limits it. So we are not even concerned about the numerator. It does not contain any roots or stuff that could limit the function. So the simple answer to this would be option B, right? Because if we draw a number line indicating this point, when we equated the absolute value x plus 3 to 0, we had minus 3. So let's say here is 0, let's say here is what? Minus 3. So since we said all real except minus 3, that means you can take values greater than what? Minus 3, you can take values less than minus 3. And then you can now see that parenthesis was used because minus 3 is not included. So from negative infinity to what? Negative 3, indicating values less than. This is negative infinity, this is positive infinity. So from negative infinity to negative 3, then union, right? Negative 3 to what? Infinity. Don't interchange the brackets, right? If you make the mistake of using this kind of brackets, that means you are including negative 3, right? Which is wrong. So the correct answer is option B. You have questions, ask. Okay. What is there again? The people are choosing to come and tell them again. We are singing His grace and my mercies continue to renew. Oh, God. Hello. This is present again. Hello. Okay, so let's move on. I see someone has joined. So taking this question, it says f of x is equal to the 19th root of 3x minus 8. I asked to find the domain of the function. So please, if you've not watched my videos on functions, all my other videos I've uploaded, they are very detailed on all these things. So if you've not watched, this is like a revision stuff. But if you've watched it, you'll know that I stated that if the root of the equation, that's if the root of the function is odd, right? That means that it can accept any value of x, whether positive or negative. And I gave the instance of the third root of what? Negative 27, right? I established the fact that third root of negative 27 is what? Negative 3. Because negative 3 times negative 3 times negative 3. So if the n that's the root is odd, that means it can accept all values from negative infinity to positive infinity. Are you following? And then, but if it is odd, just like in the case of square root of 4 is plus or minus 2, but you cannot get the square root of negative 4. The square root of negative 4 is imaginary. That is why if it is odd, you now have that it's from 0 to what? Infinity, because it does not accept negative values. That's why when you want to solve for it, you will now say, if maybe it's square root of x minus 2, and you are asked to find the domain, right? What you now do is x minus 2 is greater than or equal to 0. That's what is here. And then you say x is greater than or equal to 2, which is same as from 2 to infinity. But if what the question said was third root of x minus 2, what you're going to have is from negative infinity to positive infinity, regardless of what the function there is. Because whether it's positive or negative, it will accept the values. So the answer to this is what? Negative infinity to positive infinity. So don't make the mistake of solving any equation. Do you understand? Once this is odd, right, and there is no denominator over here, right? There is no denominator. If it was something like 1 over the 19th roots of 3x minus 8, we know that for a rational function, denominator cannot be equal to 0. So we now have to equate this to 0 to now get the value for which denominator is 0, and then say, okay, all root except. But in this case, once you just like this, you don't do anything, right? As is an odd n. So the answer is negative infinity to positive infinity. If you have any questions, please post in the comments. Okay, let's move further. If you have questions as concerns what I just explained now, post. Okay. Manager, this is not easy. Okay. So next question. Let's say we are given this. Instead f of x is equal to the square root of x minus 2 all over the greatest integer value. Let me maximize it. The greatest integer value of x negative 3. I asked for the domain of the functions, right? If you've not watched my video on how to determine the domain of a function, please do well to watch it so that you have all the details you need. So in this case, you can see a root function over here. Function given is the square root of x minus 2 all over the greatest integer of x minus 3. So in order to solve this, what do? This is a root function, and there's one rule about root functions, and in this case it's a square root function. I know that first of all, a square root function doesn't take values that are less than 0. So if it's in the exam, what I advise you to do is to equate each of these components to 0. Right? Do that as fast as possible. So if you equate x minus 2 to 0, equate x minus 3 to what? 0. So when this negative 2 moves over, what we're going to have is x equal to 2, and then in this case x equal to 3. Then draw a number line, and then locate the point that you got, which is this, right? This is 2, this is 3. So first of all, you know that this root function can only take values that are greater than what? Greater than 2. Do you understand? That is x minus 2 greater than or equal to 0, which is x greater than or equal to 2. Right? But there's something limiting it over here. So we have to consider the denominator, which is this greatest integer value function. And if you've watched my videos, you see I said in order to solve for the domain of a function that has a rational of greatest integer value function, you equate the denominator to 0 and then you equate it to 1. Because one thing about the greatest integer value function is that in between any number that lies in between 0 and 1, the greatest integer value will still be 0. Just like if you have 0.5. I play. So if we equate x minus 3 to 1, we have that x is what? 4. Because in between this 3 and this 4, the output will still be 3. Do you understand? So even though, let's say x is 3.5. If you substitute 3.5 here, 3.5 minus 3 is 0.5. And the greatest integer of 0.5 is 0. Are you following? So when we equate that to 1, we now have another region here, which is what? 4. Are you following? And then, considering this, since we said x greater than or equal to 2. Right? X greater than or equal to 2. And then, in the case of the greatest integer value function, number 1, x equal to 3. And then you have 4. Remember that this is negative infinity. This is what? Positive infinity. So it's to identify the accepted regions. First of all, you see that at x equal to 3, the denominator is going to be what? 0. And as for values in between 3 and 4, the denominator will still be 0. I remember what we said initially, that x should be greater than or equal to 2. So if x should be greater than or equal to 2, we will now restrict it because of this x equal to 3 and these ones that are in between 3 and 4. So what's your answer going to be? Starting from 2, because x is greater than or equal to 2. So use this bracket. So that is from 2 to what? To 3. And then you can see that parenthesis is used because 3 is not included. Then we use what? Union, because we are not considering values in between 3 and 4 that will still lead us to 0. And then from what? From 4, right? From 4 to infinity. Are you following? So from 2 to 3, 4 to infinity. Please ask your questions that concerns this now. Hello. Please ask your question that concerns this. Okay. And you can see that 4 was included. 4 was included in the function because if we should substitute 4 into this function, denominator is going to be what? 1. And 1 is not a problem, so 4 is included. Then you can see that we excluded 3 because at x equal to 3, the denominator is 0. And then we use the union because we're not looking at values in between 3 and 4. And that's the answer. Right? Okay. So let's look at the next question. Says if f of x is equal to the absolute of x plus 3 over 4 and g of x is equal to 2x plus 9, and the question is asking for the greatest integer value of the composite of f or g inverse of 3, right? So first of all, you have to know what g inverse is. This is the function g of x equal to what? 2x plus 9. So when you are given a function, to get the inverse, make x the subject. So we can move 9 over to this place. It becomes g of x minus 9 is equal to 2x, right? And then if you divide through by 2, you're going to have that x is equal to g of x minus 9 over 2. So we can now replace g of x as what? X. So that means that f inverse, g inverse of x will be equal to what? X minus 9 over 2. So that's g inverse. So the next thing to do now is you ask for the composite of f with g. And when you are asked, given a function like this, this is kind of like a composition. That means you implement g on f, right? So anywhere you see x in f, replace it with the inverse. That's what it implies. That's what composition is all about. So remember that f of x, according to the question, is the absolute of what? S plus 3 over 4. So since g inverse is now acting on f, anywhere you have x, replace it with what? G inverse, right? And that's going to be x minus 9 over 2 plus 3 over 4. And that's it. So the next thing now is you are asked to evaluate it at what? -3. So anyway you have s, substitute -3. And that will be what? -3 minus 9 over 2 plus what? 3 all over what? 4. And -3 minus 9 is what? Is -12. That's -12 over 2 plus 3 over 4, which is going to be what? -6 plus 3 over 4, which is going to be the absolute of -3 over 4, which will transpose to what? 3 over 4. So that's the output. But the question says, what's the greatest integer value? You can see the brackets that are used, right? So what's the greatest integer value of 3 over 4? What is it? 3 over 4 is equal to 0.75. It's not up to 1, right? If we should draw a number line, here is 0, here is 1. 3 over 4 is likely to lie in between here. And the greatest integer that is less than or equal to 3 over 4 is 0. That's the greatest integer that is less than. So the answer to this question is what? 0. That's option B. If you have any questions, do help to post. Next. Left. So let's move on to the next question. So if you are given this function 8 plus 1 over x and you ask for the range. To get it, what you simply need to do is, you can say that y is equal to 8 plus 1 over x. And from studies, you see that if you can get the inverse of the function and then determine the domain of that inverse, then it's equal to the domain, the range, sorry. So if you have to get the inverse of this function, we make x the subject, right? And in this case, x is the LCM. So we can multiply through by x, and what we have is that xy is equal to 8x plus 1 over x times x is what? 1. So we can move 8x over to the left, and what we have is xy minus 8x is equal to 1. X into y minus 8 equal to 1. And then x is equal to 1 over y minus 8. Right, following? And then so what you now need to do here is get the domain of this function. This is a rational function. And the domain of a rational function is such that what happens? The denominator cannot be equal to 0. So equate this to 0. So y minus 8 equal to 0. That means that y is equal to 8. And then at y equal to 8, you can see that the denominator is going to be 0. So that's all real except what? 8. So which we can write as from negative infinity to 8 union 8 to infinity. And the correct answer is option E. So if you're given a question in the exam and it's just in this form, right? Maybe if you are told 16 plus 1 over x, it's simply negative infinity to 16, because it can accept all values except 16 because of this stuff limiting it over here. Then union 16 to infinity, right? Okay, so let's move over to the next question. This here. You're given f of x equal to e to the power 4x plus 2, and then ask for the inverse of the function. So what you simply do here is to recognize the fact that the inverse of the exponential function is a natural log function. So since this is f of x equal to e to the power 4x plus 2, we can write this as y equal to e to the power 4x plus 2 is still the same. And then get the ln of both sides. So that would be that ln y is equal to the ln of e to the power 4x plus 2. And then since this is the inverse of this, we can then write it as ln y equal to 4x plus 2. I remember the procedure. To get the inverse, you make x the subject. So the positive 2 will move to the left to become what? Ln y minus 2 equal to 4x. And then if you divide through by 4, you have that x is equal to ln y minus 2 over 4. Right? And then you're not going to replace y with x. And that tells us that f inverse of x is equal to ln x minus 2 over 4, which is option A. So don't make the mistake of choosing option B. Option B is wrong because it's like you're not including it into the logarithm function. You just moved it over. It has nothing to do with the logarithm function. Right? So it's ln x as a covenant, then minus 2 over 4. Let's take the next question. So let's say we are given this, the square root of x negative 7 over x plus 3. And ask what's the domain. Right? And this is a root function. The fact here is that whatever is inside should be greater than or equal to 0. So x negative 7 over x plus 3 should be greater than or equal to 0, right? So what we're going to have here is equate each part to 0. You have that x negative 7 is equal to 0, x positive 3 equal to 0. And then you have that x is equal to 7, x is equal to negative 3. And then you draw a number line. This is negative infinity. This is positive infinity. Let's see here is 0. Let's here be negative 3. And then let's here be 7. So these are the two important points. So all you simply need to do here is to test values here, here, and what? Here. So if you test any value less than negative 3, for example, negative 4. If you substitute negative 4 into this function, what are we going to have? Negative 4, negative 7 over negative 4 plus 3, right? Is it greater than 0? So negative 4, negative 7 is negative 11. And negative 4 plus 3 is negative 1. Negative 11 divided by negative 1 is positive 11, which is greater than 0. So this region is approved. And if you test any value in between these two important points, minus 3 and 7, for example 0, it's a very quick substitution. So if you substitute 0 into this, it's very clear. You're going to have 0 negative 7 over 0 plus 3, and that's going to be the square root of negative 7 over 3, which doesn't even exist, right? It's an imaginary number, so this is wrong. And then if you test any value greater than 7, for example 8, right? If you substitute 8 into this, it's going to give you a positive answer, right? That's going to be 8 minus 7 over 8 plus 3, and that's the square root of 1 over 11, which exists. So this region is okay. So then the job is done. So what we're going to have is negative infinity to negative 3. Then the question is, what bracket do you use? Right? Do we use the parentheses or we use the square bracket? So test this value. If you substitute this value into the function, what are you then going to have? You substitute negative 3 into this. You're going to have negative 3, negative 7, and then negative 3 plus 3. And at this point, the function is undefined because the denominator is going to be 0. Right? So we're going to use parentheses because negative 3 is not included. Negative 3 makes the function undefined. Right? And then in union, so we've seen that values in between were wrong, right? And then you now test at x equals to 7. If you substitute 7 into this function, what are you going to have? 7 minus 7 all over 7 plus 3, which is 0 over 10. And 0 over 10 is feasible. 0 over 10 is 0, and the square root of 0 is 0. Right? So 7 is included. 7 is included. We didn't include this because this caused the denominator to be 0, right? So the union from 7 down to what? infinity, and that's the domain of the function. That's option C, right? So next up, remember, if you've not watched the videos on functions, please do well to watch that. You master everything that concerns getting the domain and all of that. And I did well to cover all the concepts as much as I could on this. So the next thing is limits and continuity. Okay, let me see. So the next thing is limits and continuity. And let's start with the revision. So the first question we have is the limit as x tends to 2 of 3x squared plus 4x plus 8. If you watch my videos on limits, I've said it multiple times. If you are given a limit, the first thing to think of is directly substituting this value that it tends to, right? So let's substitute it. So if you substitute it, you're going to have 3 into 2 squared. Now, anyway, you have x substitute 2. So that's 3 into 2 squared plus 4 into 2 plus 8. And that's going to be 3 into 4 plus 8 plus 8. And that's 12 plus 8 plus 8, which is 28. And that's option A. Are you following? That's option A. So what's this going to be? I want you to let me have your answers in the comment section. What's the answer to question 2 by direct substitution? The limit as x tends towards -1 of 3x negative 4 over x squared plus 9x negative 4. Please, I want to see your answers. Please, I need answers to this question I just showed up right now. This question, I want to see your answers. Limit as x tends towards -1 of 3x minus 4 over x squared plus 9x minus 4. Is it 0.5, 7 over 12, 0.75, 4 over 3? Do you have answers? Hello? No answers? This is the question, in case if you are not seeing it. This is the question, post the answer. Post your answer. Post your answer. Please post your answers, though. Post your answers. Is it 0.5, 7 over 12, 0.75, 4 over 3? I've not gotten a response, so. Okay. One is responding. Okay, so all you do here is to directly substitute -1, and then what we're going to have is 3 into -1, -4, all over -1 all squared plus 9 into -1, -4, and that will be -3, -4, all over -1 all squared is 1, and then 9 times -1 is -9, and then -4, right? And that's going to be -7 over 1 -9 is -8. -8, -4 is -12, and that's +7 over 12. And then correct answer is B, 7 over 12. Right? So still following the same principle, question 3. if you directly substitute 0 into this function, if you are asked this question in the exam, if you directly substitute, what you have is minus 2 plus 0 all over 0 squared. And that's going to be what? Minus 2 over 0. And what is minus 2 over 0? Minus 2 over 0 is undefined, right? And anytime you solve and then you find out that the numerator is a constant while the denominator is 0, in this case we had negative 2 over 0, it shows that the limit does not exist. So don't make the mistake of choosing 0 as the answer, right? Negative 2 over 0 is not same as 0 over negative 2, right? So the answer is actually none of these, right? And then the right answer is that it does not exist. The limit does not exist. Take note. And if you've watched my videos, you know that we have different types of things like this. We have removable discontinuity, we have essential discontinuity, we have jump discontinuity. In this case, this is called essential discontinuity, where you have a over 0, right? Where a is not equal to 0, right? The limit does not exist. But if maybe after substitution, and then at the end of the day you have 0 over 0 after substituting, hello, yeah.
That lecture thing we're doing, is it public?
Yes, it's public.
Like, after it, can the video be available so that people can watch that, right?
Yes, it's available. Yeah. Okay, so the next question. So as I was saying, if it's now 0 over 0, you have what's called removable discontinuity, and removable discontinuity shows that the limit exists, right? And then if it's jump discontinuity, the left hand limit is not equal to the right hand limit. So let's see this question. The limit as x tends towards 0 of negative 1 plus cos x all over x squared. So what are you going to do here? What you're simply going to do here is directly substitute. That's the first step. So if you substitute 0 into the function, you're going to have negative 1 plus cos 0 all over 0 squared. The question now is, what is cos 0? It's important to note, you studied 3, that cos 0 is equal to 1. Very important. So negative 1 plus 1 over 0 is equal to what? 0 over 0. So number 1, don't make the mistake of choosing 0. The fact that after substituting you have 0 over 0 shows that the function is undefined at x equal to 0, but the limit exists. And for you to solve for such functions, what happens? You're going to employ L'Hopital's rule. And what does L'Hopital's rule say? In this case, we have negative 1 plus cos x over x squared. So all we simply need to do is to differentiate the numerator, differentiate the denominator, then try substituting the values. So if we should differentiate negative 1, if you've not watched my video on derivatives, do well to watch it. If you differentiate negative 1, it's going to give you what? 0. If you differentiate cos x, it's going to give you what? Negative sine x. Are you following? And then if you differentiate numerator, which is x squared, what are you going to have? 2x. Because 2 comes down, right? And then you find out that if you try substituting 0 again, sine 0 is 0, very important. Right? Sine 0 is 0, cos 0 is 1. So if you try substituting 0 again, you still end up with 0 over 0. So what do? Repeat the process again. So if you should then differentiate sine x, negative sine x is going to be what? Negative cos x. And then if you differentiate 2x, what are you going to have? 2. So what we now do is to try substituting 0 again. So if you substitute 0 into this, what we have is negative cos 0 over 2, which is negative 1, because cos 0 is 1, right? And then that's negative 1 over 2, and the answer is option B, negative 1 over 2. If you have questions, please post in the comments. So next question. The limit as x tends towards 0 of negative x plus sine x over x squared. Limit as x tends towards 0 of negative x plus sine x over x squared. So what we're going to have here is the same thing, directly substitute. So if you directly substitute, what we're going to have is going to be negative 0 plus sine 0 all over 0 squared. So that's going to be what? 0 over 0. And 0 over 0 is an indication that this limit exists, but it's undefined at this point. So what do? Differentiate each component. Right? So we have negative x plus sine x over what? X squared. So if we should differentiate the numerator, what we're going to have is negative 1. If you differentiate negative x, you have negative 1. And then if you differentiate sine x, you're going to have cos x. And then all over, if we should then differentiate this, if you differentiate x squared, what are you going to have? 2x. And then you find out that if you substitute 0 again, you are still going to end up with 0 over 0. So repeat the process. So now, if you should differentiate negative 1, what are you going to have? You're going to have 0, right? And then if you differentiate cos x, it's going to give you negative sine x, right? And then all over, if you should differentiate 2x, you're going to have what? 2. So what do? Substitute 0 into this. If you substitute 0 into this, what are you going to have? That will be negative sine 0 all over 2. And sine 0 is 0. Right? So the answer is 0. Right? So that's the answer to the question. So first of all, we differentiated numerator negative 1 plus cos x. Differentiated again negative sine x over 2. Right? Then at that point, we then substituted 0 again. Right? So the answer is option A, 0. Okay. Let's take other questions. Let's say I given the limit as x tends towards 0 of cos 7x minus 1 all over x sine x. So in this case, what you're going to have is substituting 0 into this. You have cos 0 minus 1. That's cos 7 times 0 minus 1 over 0 sine 0. Which is going to end up with 7 times 0 is 0, cos 0 is 1. 1 minus 1 is 0. And that leaves us with 0 over 0. So we can then use L'Hopital's rule. So in the case of cos 7x over x sine x minus 1 over x sine x, we should differentiate cos 7x. What are we going to have? We use the u substitution, right? And so let u be equal to 7x, and then du over dx is equal to what? 7. Are you following? And then dy du. We should differentiate cos. What are we going to get? Sine. So differential of sine cos u is what? That's negative sine u. Sorry, negative sine u. If you multiply this with this, we have negative 7 sine u, which is negative 7 sine 7x. Are you following? So we can replace this with negative 7 sine 7x, and then remember that the differential of a constant is what? 0. Then all over, if we should then differentiate the denominator, can use product rule, right? Let's say this is u, this is v. So that, remember that product rule is v du plus what? U dv. So v is sine x. To differentiate, you are going to have what? 1. That's if you differentiate x, you're going to have 1. And then plus u, which is x, multiplied by dv. If you differentiate sine x, you're going to have cos x. So what we have here is what? Sine x plus x cos x. Right? And then we find out that if you should then substitute 0 into this, you are still ending up with 0 over 0. Because if you substitute 0 here, sine 0 is 0. If you substitute 0 here, 0. You substitute, there is an x here that will lead to a 0, right? So what do? You repeat the process again. So if you should differentiate negative 7 sine x, what's it going to be? It's simply negative 7 multiplied by the differential of sine 7x. And it's very easy. You can say let 7x be equal to what? U. And the u over the x is what? 7. So 7 multiplied by, if you should differentiate sine u, what will you get? Cos u. And that will be what? 7 cos 7x. So we can multiply negative 7 with what? 7 cos 7x. And that will be negative 7 times 7 cos 7x all over. If we should now differentiate sine x, we're going to have what? Cos x plus. And then for x cos x, what are we going to have? Use product rule, right? Let this be u, let this be v. So that will be cos x multiplied by du, which is 1 plus x multiplied by dv, right? If you differentiate cos, remember you're going to get what? Negative sign. So that's cos x plus x minus sine x, right? And then after that, what are we then going to have? Negative 49 cos 7x all over cos x plus what? X negative sine x, right? And then you can now try substituting 0 again. You substitute 0 into this, what we're going to have is negative 49 cos 0, because 7 times 0 is 0, all over cos 0 plus cos 0 plus 0, because x is 0, right? We are substituting x as 0. So this will cause everything here to be 0. So that will be, remember cos 0 is 1, right? So that will be negative 49 all over cos 0, which is 1, and then cos 0, which is 1, and then that's negative 49 over 2. So the correct answer to this is option C, negative 49 over 2. Right, so I just expose you to this because they may now want us to apply the rules of differentiation to solve and then carry out the differentiation multiple times. Right? So let's take more questions. So if you are given this in the exam, what are you going to do? Same process. Substitute 0. So if you should substitute 0 into this, what are you going to have? You should substitute 0 here. We're going to have 0 sine 0 plus 2 cos 0 minus 2 all over 0 to the power 4, which is going to leave us with 0 all over 0, right? Because 2 cos 0 is 2, cos 0 is 1, 2 minus 2 is 0, everything is 0. So we then have to differentiate up and down. And this is what we are given. X sine x plus 2 cos x minus 2 over x to the power 4. So if we start differentiating x sine x, what are we going to get? It's going to be x cos x, right? Plus what? Sine x. Using product rule. And then if you should differentiate 2 cos x, it's simply 2 times the derivative of cos x, which is what? Negative sine x. And then negative 2. Then all over, if you should then differentiate x to the power 4, what are you going to have? 4x to the power what? 3. Are you following? So what we're going to have here is simply x cos x plus sine x, and then 2 times negative sine x is negative 2 sine x minus 2 all over what? 4x cubed. We must do this fast too because there is no time. So sine x minus 2 sine x is what? Minus sine x, right? and then that's minus sin x minus 2 over 4x cubed. Then you repeat the process again, because you find out that if you substitute 0 into this, you are still going to end up with 0, right? Because if you put 0 here, 0, if 0 is inserted here, you have 0, right? So if you should carry out the process again, what is that going to give us? If you should differentiate x cos x, it's going to be, that's going to be x negative sin x, and then plus cos x negative sin x negative 2 all over, we differentiate 4x to the power 3, it's going to leave us with what? 12x squared, right? And then with that, we are having negative x sin x plus cos x minus sin x minus 2 all over 12x squared. The same thing happens again. You repeat the process, because at the end of this, if you substitute 0 here, I'm still going to have 0. Okay. So if you should differentiate negative x sin x, what we're going to have is negative x cos x. Then if you differentiate negative x, you're going to have negative 1, right? So this is u, this is v. So that's negative x multiplied by the derivative of sin x, and then sin x multiplied as negative 1, right? Negative sin x plus sin x, negative sin x, because if you differentiate cos x, you're going to have negative sin x, and then negative sin x, then negative 2. It's actually taking time. Okay, so please let's move to another question, right? But this question is quite time consuming. You have to differentiate to the point where you have a constant underneath. So let's take another one so that I don't waste your time, because I don't believe it will make it so complex. So for my point here is I'm doing a simple function, most likely because it's an OBJ exam. Look at it, directly substitute, and then after direct substitution, what do? Just like this kind of question is a very good question that could come out. I saw it in one of the past questions. So what simply do? Substitute. If you are ending up with 0 over 0, you start the differentiation. I'm not sure they're not likely to set anything that will waste the time. Okay, so let's say I'm giving this question now. Earlier in this series, I talked about 3 types of discontinuities. We talked about removable discontinuity, talked about jump, and we talked about essential. So this question is asking for what values of x is the function said to be discontinuous. If you should see this type of question, what do you simply do? Discontinuity means that there's, when something is continuous, something is continuing, there is no breakage along the line, right? And this discontinuity occurs when the denominator equals 0, right? Because at that point the function is undefined. So in this case, your job is to simply do what? Equate the denominator. You don't have any business with the numerator. Equate the denominator, which is x cubed minus 6x squared plus 8x. You equate it to 0, and then you can see that x is common, right? So if you factor out x, you're going to have x into x squared minus 6x plus 8 equal to 0. Right? So what do you do next? You can see that this is a quadratic equation that you can easily factorize. That's why this thing is easy. So you can look for 2 numbers that you add, that you get negative 6, you multiply, you're going to get 8, and that's negative 2, negative 4. and that's going to be x into x squared negative 2x negative 4x plus 8 equal to 0, and that will be x. Then you have x into x negative 2 minus 4 into x negative 2 equal to 0. So with this, we can now take this and this, right? And factorization. Then we have x into what? X minus 4 into x minus 2 equal to 0. And then the next step is to equate each of these components to 0. You now see that x is equal to 0, or x negative 4 is equal to 0, or x negative 2 equal to 0. That means that x is equal to 0, x equals 4, x equals 2. So at these values, what happens? Denominator is what? 0. The correct option is what? Option B, 0, 2, and 4. So if I give you any problem, just like they give you something like this in the exam, f of x equal to 3 plus x over 5 minus x, and you're asked, for what value is it discontinuous? Simply what? 5 minus x equal to 0. It's simply what? 5. Don't make the mistake of equating this. You're not going to equate the numerator to 0, right? So that's it. Now this is another major type of problem they are likely to face. This kind of thing. And it says, for what value of k is a function defined by f of x equal to x minus 2 over the absolute of x minus 2, x greater than 2, right? And then you have k plus 3, x less than or equal to 2. So when you just see this kind of thing, don't get scared. The main principle here is that the left hand limit, remember that for a function to be continuous at x equal to c, the limit must actually exist. And that actually implies that the left hand limit should be equal to the what? Right hand limit. And if you watch my videos, we discussed that left hand limit is the value of the function as it approaches from the what? If it's left hand, from the left, from the right. So they should be the same. And you can say that this one is what? Greater than, this is less than. So when you get the limit at this point, it should be equal to the limit of this. Then you equate it and get it. So if you are now to simplify this, which is x minus 2 over absolute of x minus 2, what is it going to be? If you have to simplify the absolute of x minus 2, it's actually going to be what? X minus 2, right? You know, it's possible for it to be negative x minus 2, because absolute of negative x minus 2 is still x minus 2. But since the question said x greater than 2, if x is greater than 2, there is no way what is inside there will be negative. If you start calling numbers greater than 2, like 3, 4, if you substitute 3 into this, 3 minus 2 is 1. So we are not looking at negative values. So it's just what? X minus 2. So when x minus 2 then cancels x minus 2, we are left with what? 1. So this is the, in this case, it says x greater than 2. This is the right hand limit. Are you following? And then this right hand limit should be equal to the left hand limit, which is this x less than or equal to 2 region. So this k plus 3 should be equal to what? Should be equal to 1. Because you can see that this other part, it doesn't have any function of x. If it had x in it, maybe if there was 3x, you just substitute 2. Right? If maybe it was k plus 3x, you substitute 2 because it's continuous as x equals. You are getting the value for which is continuous. Are you following? So what you're not going to have here is the plus 3 moves to the right. And what happens? K will be equal to what? 1 minus 3, which is what? Negative 2. So please, with what I just explained, I want you to answer this question. You can put your answers in the post. F of x equal to x squared negative 3x plus 9, x less than or equal to 2, kx plus 1, or x greater than 1. I asked, for what value of k is the function continuous at x equal to 2? So please, I need answers. Just put out what you think. Post your answers and let's see. Post your answers and let's see. Okay, I'm not seeing answers. So please post your answers. Post your answers to this question. For what value of k is the function continuous at x equal to 2? Okay, so in order to solve this, it's the same principle. You get the left hand limit, and the left hand limit should be equal to the what? To the right hand limit. So if you directly substitute 2 into this function, because what I'm given first is x squared negative 3x plus 9, right? So the left hand limit should be equal to the right hand limit. So if you evaluate the function as x tends towards 2 from the left, what's that going to be? 2 squared minus 3 into 2 plus 9. And that's simply 4 minus 6 plus 9, which is negative 2 plus 9, which is what? 7. That is the what? Left hand limit. So this left hand limit should be equal to the right hand limit. Are you following? It should be equal to the right hand limit. So that means when it's now substituted into the second function, and the second function is kx plus 1, right? Kx plus 1. So it should be equal to the right hand limit. So if you substitute 2 into this, anywhere you have x, substitute 2 is going to be 2k plus 1 equal to what? 7. This is the left hand limit. After substituting x into this, we are now equating it to the left hand limit from what? X squared negative 3x plus 9. Right? And that will be 2k equal to 7 minus 1. And that will be 2k equal to 6. That means that k is equal to 3. And that's the answer to the question. That is the value of k for which the function is continuous at x equal to 2. Okay, so let's take the next question. They ask for the limit of, we're now looking at infinite limits, right? And if you study limits, you know that it's very important to know that the limit as x tends towards infinity of 1 over x is equal to what? Is equal to 0, right? So in this case, all you need to do is to look at what you have. This is the limit as x tends to infinity of 4x all over the square root of x squared minus 1. The question you now ask is, what's the highest power of x in this expression? And don't make the mistake of saying x squared, because the x squared you are seeing is inside the root function. And if you have a root function containing x squared, it implies that the final power is going to be x, because the square root of x squared is x, right? So the highest power is x. Don't make the mistake of dividing by x squared. You divide by x. X is the highest power, because this x squared is in a root function, which still leads to what? X. So divide each part, which is numerator and denominator, by x. And if you should do that, what you're going to have is what? 4x over x divided by the square root of x squared minus 1 over x. Are you following? So this then cancels this. And then in this case, you can replace this with square root of what? X squared. So instead of x, we can now replace it as what? Square root of x squared, which is still x. We're just trying to achieve something. So what we then have is what? 4 over, we can now combine these two roots. That's the limit as x square root of what? X squared minus 1 over x squared. So if we simplify this part, what we're going to have is 4 over square root of x squared over x squared is what? Is 1. And negative 1 over x squared is negative 1 over x squared. Right? And then since the limit as x tends to infinity of 1 over x is 0, this compartment is simply what? 0. So the final answer is 4 over the square root of minus 1. And the square root of, that's 4 over square root of 1. because the limit of these parts containing negative 1 over x squared is 0. So that's 4 over 1, which is 4. So the correct answer is option D. So let's move to the next question, question 12. And it says limit as x tends towards infinity of 2x squared minus 3x plus 8 over 3x squared plus 9x plus 11. So in that case, what are we going to have? All you simply do there, so divide by the x power. In this case, the x power is x squared, right? So what we're going to have is 2x squared. This is to take a minute. Okay, so that's 2x squared over x squared negative 3x over x squared plus 8 over x squared, and then all over 3x squared over x squared plus 9x over x squared plus 11 over x squared. So this cancels this cancels this, and then that's going to be 2 minus 3 over x plus 8 over x squared all over 3 plus 9 over x plus 11 over x squared. And then since all these parts contains are factors of what? 1 over x, I know that the limit as x tends towards infinity or 1 over x is 0. All of this amounts to 0. So the final answer is 2 plus 0 plus 0 all over 3 plus 0 plus 0, which is 2 over 3. And the correct answer is option B. Let's move on to the next question. This question is similar to the question we tackled some minutes ago, right? So what you simply do here is equating the components you have here. You have x squared, you have x4. So the question now is, what's the highest power of x here? You can see that this x to the power 4 is in a root function. So the highest power of x is x squared, right? Because the square root of x to the power 4 is still going to lead to what? It's still going to lead to x squared. So divide through by what? X squared. So what you're going to have is 3x squared over x squared plus x over x squared negative 6 over x squared over the square root of 5 minus x plus 4x to the power 4 all over what? X squared. And if you simplify this side, we are going to have 3 plus 1 over x negative 6 over x squared, and then that's all over. If you are going to simplify this part, we can write x squared as square root of x4. So we can write everything as square root of 5 negative x plus 4x to the power 4 all over x to the power 4. So with this, we can then simplify as square root of 5 over x to the power 4 negative x over x to the power 4 plus 4x to the power 4 over x to the power 4. So this cancels this, right? And then you can see that all these parts are factors of 1 over x, which is going to tend to 0. Are you following? So if we should simplify, and then the same applies to the numerator. The same thing applies to the numerator. All these parts is also going to tend to 0 because it contains x. That's 1 over x. This also contains 1 over x because that's 6 over x times 1 over x, right? And then product of limits, limit of the product, right? So what we're going to have is 3 plus 0, and say minus 0 over square root of 0 minus 0 plus 4, which is 3 all over the square root of 4, which is 3 over the square root of 4 is 2, right? And that's going to be what? 3 over 2. That is the answer to the question. And that corresponds to option D. Let's take this question. We are now in derivatives. So given f of x equal to 4x to the power 3 plus negative 9x squared plus 11x negative 5, and you are to get the first derivative of negative 1. So if you should differentiate this, right, what are you going to have? 3 comes down, that's going to be 12x to the power 3 minus 1, minus 2 comes down, it becomes 9 times 2, x to the power 2 minus 1, then plus, we differentiate 11x, we're going to have 11, and then differential of the constant is 0. So since we are asked for first derivative at what? Minus 1. When you see this side, first derivative, is that you say first derivative at minus 1, or maybe the y, find the y dx, right, at x equals to minus 1. Still the same thing. So what we now have is 12x squared negative 18x plus 11. So anywhere you see x, substitute negative 1 in this first derivative. So that implies that this is equal to 12 into negative 1 all squared, negative 18 into negative 1 plus 11, and that's going to be 12 plus 18 plus 11, which is equivalent to what? 41. Because 12 plus 18 is 30. 30 plus 11 is equivalent to 41. Right? Let's take other questions. Let's say I'm given this f of x. F of x equal to the fifth root of x to the power 6 plus e to the power 3x plus 2. And then plus 4 sine 2x. It's just to differentiate each part. And from index laws, to differentiate this part, you know that the nth root of x to the power a is equal to what? X to the power a over n, right? So in the case of this, we can write square root of x 6, 5 as x to the power 6 over 5. And then via the basic principle that says given x to the power n, the differential is nx to the power n minus 1. So in this case, what we're going to have is 6 over 5x to the power what? 6 over 5 minus 1. Right? So 6 over 5 comes down, and then you have that 6 over 5 x to the power 6 over 5 minus 5 over 5, which is 6 over 5x to the power 1 over 5. Right? And then in the case of e to the power 3x plus 2, you should know that e to the power u is, if we differentiate it, it's still going to be e to the power u. So since u is equal to 3x plus 2, what are we then going to have? Du dx is equal to what? 3. And then dy du is still going to be e to the power u. So when this e to the power u multiplies this, what we're then going to have is what? 3e to the power u. Which is, and then you now recall that u is what? 3e to the power 3x plus 2. And then for the last part, we have 4 sine 2x. If you are to differentiate 4 sine 2x, what is it going to be? You're going to say let u be equal to what? 2x. So du over dx will be equal to 2. And if you should say let y be equal to sine u, that means dy du is equal to what? Cos u. So when you multiply this with this, you're going to be left with what? 2 cos u. And then you now recall that u is what? 2x, which is 2 cos 2x. Then you multiply by this 4. Remember, we exempted 4. So 4 times this 2, we're going to have what? 8 cos 2x. And you can see that the answer is not in the options, because the first derivative of nth root of, that's fifth root of x to the power 6 is 6 over 5x to the power, but the other ones are correct. So the correct answer is 6 over 5x to the power 1 over 5 plus 3e, which we got over here, to the power 3x plus 2, and then finally we got 8 cos 2x as the final part. Okay, so let's take this question. If y is equal to 2x squared minus 3 to the power 8, I asked for the first derivative at x equal to 1. So in order to solve this derivative in the first place, you have to employ the chain rule, right? So what I'm going to say is let u be equal to coming. So what I'm going to say is let u be equal to 2x squared minus 3. So if you differentiate this, the u over dx will be equal to what? 4x. Then you can now write y as what? U to the power 8. Right, following? So dy du, following the principle, 8 comes down, right? So it's going to be 8u to the power 8 minus 1, which is 8u to the power 7. So you multiply dy du with what? Du dx. So if you multiply 4x with 8u7, what's that going to be? It's going to be 32x u7. And then you now recall that u is what? 2x squared minus 3. So that's going to be 32x into 2x squared minus 3 to the power 7. And then what you just have to do here is anywhere you have x, substitute 1. Hopefully, if you substitute 1 into this, what are you going to have? 32 into 1 into 2 into 1 squared minus 3 to the power 7. And that's going to be 32 into minus 1, because 2 minus 3 is what? Minus 1. And minus 1 to the power 7 is what? Minus 1. Minus 1 raised to an odd number is always minus 1. So that's what? Minus 1 times 32. And that's negative 32. And that's option D. Okay. Let's take this question. We are given this y is equal to ln of the square root of x squared plus 5x plus 3. Right? Y is equal to the ln of square root of x squared plus 5x plus 3. So how are you going to do it? You first of all know the natural log laws. I can see that this is a root. So we can write this as ln of x squared plus 5x plus 3 to the power half. Are you paying attention? Because this is a root. It's still the same. Just like if you have 4 to the power half, it's the same thing as square root of 4. Right? And according to the logarithm laws, you can move this half to the back, right? So that's going to be half ln x squared plus 5x plus 3. And then we can move on with the differentiation. Are you following? Via what? Use substitution. So what we're now going to do here is to say, let u be equal to x squared plus 5x plus 3, right? And then du over dx is going to be what? 2 comes down, right? It's going to be what? 2x plus 5. And then we can now say that let's say y1 is equal to what? Ln u, because what we had is ln x squared plus 5x plus 3, right? X squared plus 5x plus 3. So y, let's leave out the half, and then later we'll multiply half by our final result, right? So what I'm now going to have here is, we should differentiate ln u. It's very important to know that differential of ln x is what? 1 over x. So differential of ln u is going to be what? 1 over u. So 1 over u multiplied by this half that was at the back times half multiplied by du dx. Because remember that dy du times du dx is what? Dy dx. So multiplied by 2x plus 5. So that's going to be what? 2x plus 5 all over 2u. You will now recall that u is what? S squared plus 5s plus 3. Are you following? That will be 2s plus 5 all over 2 into x squared plus 5x plus 3, and that will be 2x plus 5 all over 2x squared plus 10x plus 6, right? And then the correct answer to that is option B, right? Okay, let's take more questions. So in this case, they are giving y equals to 6 to the power x plus x to the power negative x. I are asked for the value of dy dx. This part is very important and it's not difficult. All you have to understand is that when you have exponents, don't make the mistake of saying 6 to the power x, then x coming down. You now have x 6 to the power x. That's wrong because it's x you are differentiating. The only time we do this is if there's a constant as a power, right? So in order to solve this, solve it bit by bit. So solving this bit by bit, what are you going to have? If you say let y1 be equal to 6 to the power x and let y2 be equal to what? 6, the other part says x to the power negative x. Now pay close attention. So what I'm going to have here is you just employ the ln function over here. So what you now have is that ln of y1, anytime I given an exponent, because it's the logarithm function that breaks it down, is equal to the ln of 6 to the power x. Are you following? And then what do you do next? Using the logarithm law that says that log or ln of a to the power n or ln of x to the power n is equal to n ln x. That means the n can move over to the back, right? So we can write this as ln y1 is equal to x ln 6. Do you understand? And then you start your differentiation. To differentiate ln y, what are you going to get? It's going to be 1 over y dy dx, right? And then if you should differentiate, because you are differentiating according to y, so you attach dy dx. Then if you should differentiate x ln 6, you know that ln 6 is a constant, right? So x is what you are differentiating. And if you differentiate x, what are you going to get? 1. So what is it? It's just ln 6, right? Because x ln 6 is simply ln 6 times the derivative of x, which is 1. So we can now cross multiply, right? So we can say that dy1 over dx is equal to what? Y ln 6. You will now recall that y is what? 6 to the power x. That's y1. So that means dy dx is what? 6 to the power x ln 6. Do you understand? Then let's move to the other part. Same principle. You can try it out. So in this case, what you're going to do, ln y2 is equal to the ln of x to the power negative x. So what happens? Negative x comes down, right? So it becomes ln y2 is equal to negative x ln x. Right, following? And then same thing. It's going to be 1 over y dy dx. But you must be careful here because in this case, you're having x here, having x here. So you have to use what? Product rule. So if you say let here be u, let here be v. And remember what product rule says? V du plus what? U dv. So what is v? Ln x, right? And then if you differentiate u, if you differentiate minus x is what? Is minus 1, right? And then plus u, which is what? Negative x times dv. If we differentiate ln x, what do we have? 1 over x, right? So that's 1 over x. So what are we then going to have? That'll be 1 over y2 dy2 dx is equal to negative ln x. And then this x can cancel this, right? And then I'm going to be left with what? Negative 1. Are you following? And then to now make the y dx the subject, this now crosses over. That means that the y2 over dx is equal to what? Y2 into negative ln x minus 1. Are you following? And then you now recall that y2 is what? X to the power negative x. Do you remember? X to the power negative x. So you now replace it with what? X to the power negative x. So what you have is x to the power negative x of negative ln x negative 1. Do you get? And then you can factor out this negative. That's alright. That's negative x to the power negative x into ln x plus 1, right? That's like a factorization. So we can bring this and this together as 6 to the power x ln 6 minus x to the power negative x. That's what we got here, into ln x plus 1. And in this case, guess it's that's option A, 6 to the power x ln 6 minus x to the power negative x into 1 plus ln x, or you can see ln x plus 1. It's still the same thing. So next question, y equal to e to the power 3x sine 4x plus 2. So how are you going to go about it? Use the product rule, right? So if here is u, if this is u and this is v, remember what the rule says, and you can see how the question was put. The y, if you are given this, it's still the same thing as differentiate it. So don't get confused, right? So what we're going to employ here is v du plus u dv, right? So what's v? That's sine 4x plus 2, and then multiplied by du. If you differentiate e to the power 3x, what's it going to give us? You use a mini u substitution, right? If we should say let u1 be equal to 3x, if we differentiate 3x is what? 3 multiplied by, if we now differentiate e to the power u, which we've called 3x, right? Remember that if you differentiate e to the power u or e to the power x, is still going to be the same thing, right? So that's going to be 3 times e to the power 3x. Are you following? Then plus u, which is e to the power 3x multiplied by what? Dv. If you are to differentiate sine 4x plus 2, you create a mini u substitution. You say let u2 be equal to 4x plus 2, and then if you differentiate it, du over dx is what? Is 4. And then y, so let's call it a small y, is equal to what? Sine u. And if you differentiate sine u, what are we going to get? Cos u. So we multiply cos u with what? 4. And that's going to be 4 cos u. We now recall that the u2 is what? 4x plus 2. So that's 4 cos 4x plus 2. So at the final answer, the best written as 3x sine 4x plus 2 plus 4e 3x, and then cos 4x plus 2. And that's it. That's the answer to the question. That's the answer to the question. Okay, so that's it. I've expanded on my questions, but I want to take more questions from the PDF I got on the Maths 103 question. So with all of this course, you should be able to answer question 1, 2, getting the inverse, getting the domain, right? Getting the domain of the function and all of that. If we should take question 3, right? Even in the case of question 3, you can see that there is a denominator here, x minus 3, and then there's a root function. So we have to solve this. What are we going to have? X minus 3 should be greater than 0. It shouldn't be greater than or equal to 0, right? Because if it's equal to 0, what happens? Denominator is equal to 0, and that's not allowed. So that's why we just have to, it has to be greater than 0, right? So when this negative 3 crosses, what we have? X greater than 3, and that's still same as from 3 to what? Infinity, and that's option C. In this case, you should also be able to answer the square root of x minus 2 and x minus 3. Draw a number line, right? And if this is 0, this is 2, and this is 3, because if you create x minus 3 to 0, you're going to get 3, right? And then this is a root function. This is a root function. So, and one thing here is that x minus 2 should be greater than or equal to 0, right? And another thing here is that x should not be equal to 3. X cannot be. So x can be greater than or equal to 2, but x can be 3, because at x equal to 3, what happens? The denominator is going to be 0. So x can be greater than 2, but at this point we are going to restrict it. So that's why the answer is going to be from 2, because 2 is inclusive, right? Because at 2 you're going to have 0 over, which is valid, then to 3. We are now using this to exempt 3. That's why we use parentheses, and then union from 3 to what? Infinity. That is other numbers greater than 3. So the main point here is x can be greater than or equal to 2, but it mustn't be 3. So we have to include it, exempt it. Hopefully. Question 5, you should be able to solve it based on what we discussed. The question we solved, where we were talking of what do you call it, 8 plus 1 over x, where we got from negative infinity to 8 and then union 8 to infinity. So in this case it's simply negative infinity to 2, then union 2 to infinity, right? And then in this case you should also be able to solve this problem. Question 6, f of x equal to the absolute of x plus 2 and g of x is equal to 2x plus 1. I ask for f o g inverse, right? So if you should get the inverse of this function, what do you simply do here? You move positive 1 to the left hand side. You move it to the left hand side. So sorry. If you move it to the left hand side, what we have is g of x minus 1 equal to 2x, which implies that the inverse of g is equal to what? X minus 1 over 2. So since it's FOG inverse, that means we're now going to plug x minus 1 over 2 into the f function. That is, anywhere you have x, replace it with x minus 1 over 2. And by the time you simplify x minus 1 over 2 plus 2, what are we going to have? It's the same as x minus 1 over 2 plus 4 over 2. So sorry for that. Plus 4 over 2. And x minus 1 plus 4 is what? Is x plus 3. Right? X minus 1 over 2 plus 2 is x minus 1 over 2 plus 4 over 2. And x minus 1 plus 4 is what? X plus 3, and then all over 2. That's option A. In this case, all you simply need to do is substitute 0.5. Anywhere you have x, substitute 0.5. What's the other side of 0.5? It's going to give us what? It's going to give us 1, because it's greater than 0, right? And then this is an absolute value function. If you substitute 0.5 into this, 3 minus 0.5 is what? Is 2.5. And the greatest integer value of 2.5 is 2, because that's the greatest integer less than or equal to that value. That's 2 over the signum of x plus 1. If you substitute 0.5, that will be the signum of 2.5. And since 2.5 is greater than 0, the signum is what? 1. And 1 plus 2 is what? 3. So the final answer is what? 3. Are you following? Question 8 was one of the questions I solved in this video, right? That's where I picked the question from. Question 9, we've solved it before. Question 10, we've solved it. And then for question 11, we are given y equal to 2 cos 2x plus 1 minus 3 sine 2x minus 1. So let's solve it. We are given y equal to 2 cos 2x plus 1 and then minus 3 sine 2x minus 1. So what are we going to have here? And the question is asking for the second derivative, because you can see that there are two apostrophes over here, right? So the second derivative. So to get the second derivative, we differentiate it the first time and then differentiate it again, right? So in this case, we differentiate part by part. It's simple. Remember, you have to be fast. You can make a mini u substitution and say let u be equal to 2x plus 1. And then if you should differentiate this part, you're going to get 2, right? And then taking y as, let's say y1 is equal to 2 cos u, right? That means that the y1 over du is equivalent to negative 2 sine u, because differential of cos is minus sine. Are you following? So if we then multiply by du dx, what's that going to be? Negative 4 sine u. And you now recall that u is 2x plus 1, right? So that's negative 4 sine 2x plus 1. And then in this case, negative 3 sine 2x minus 1. What are we going to have? We're going to say let u be equal to 2x minus 1, du over dx equal to 2, and then a mini y2 equal to negative 3 sine u. And then if we should differentiate that, that's going to be negative 3 cos u. And then multiplying this with this, we have negative 6 cos u, right? And that's negative 6 cos 2x minus 1, because that's the value of u in this case. So we can bring everything together as negative 4 sine 2x plus 1 minus 6 cos 2x minus 1. And then this is the first derivative, right? And then to get the second derivative, we go again. So the same process again, right? If you differentiate 2x plus 1, is going to give you what? 2. So 2 times negative 4 is negative 8. And then remember that differential of sign is what? That's cos, right? Cos of what? 2x plus 1. Then negative 6, right? If we differentiate 2x negative 1 is what? Is 2. Multiplied by, if we differentiate cos u is what? Negative sine u, which is 2x minus 1. And that's negative 8 cos 2x minus 1. Then negative 6 times 2 is negative 12. And then this negative makes it a positive. And then that's plus sine of 2x minus 1. Right? And you can see that the options leave left the answers in terms of y. Option A said negative 4y, negative y, negative 9y, and then y, right? So what I'm going to do here now is simply factor out this expression. And if you factor this out, the common factor here is negative 4. So negative 8 cos 2x minus 1 divided by negative 4 is what? 2 cos 2x negative 1, and then positive 12 sine 2x negative 1 divided by negative 4 is going to be negative 3 sine 2x negative 1. And then did you remember that this entire function is equivalent to what? To y. That was the original function given. 2 cos 2x plus 1 minus 3 sine 2x minus 1. Same function. So we can write second derivative as negative 4y. That's the answer to the question. So the answer to this is negative 4y, option A. Right? Question 12. I've solved it in one of my YouTube videos. Go to my channel page and you see where I solved question 12. Right? Elaborately. So in this case, I have also solved this on my channel. Go and watch the video. In the case of question 14, we have x equal to e to the power t plus cos t. X is equal to e to the power t cos t, and y is equal to e to the power t plus sine t. So this is a parametric equation, right? So all we simply need to solve is the y dt times dt dx. So if we should differentiate the y, that's the y dt. If you differentiate e to the power t, it's still going to give you e to the power t, right? And then if we should differentiate sine t is what? Cos, right? And then to get dt dx, first of all get dx dt. If we should differentiate x with respect to t, what we're going to get is e to the power t is what? If we differentiate it, it's still going to be e to the power t. And then if we differentiate cos t is negative sine t. And that's e to t negative sine t. Right? And then since we are looking for dt dx, it's simply the inverse, right? So dt dx will be equal to 1 over e to the power t minus what? Sine t. So we multiply this dt dx with dy dt. And that's going to be e to power t plus cos t multiplied by 1 over e to power t negative sine t, right? Which is going to be e to power t plus cos t all over e to power t negative sine t, right? And that is the answer to the question. In this case, that's e to power t negative cos. Is it negative cos? Or that's positive cos t all over e to the power t negative sine t, which is option D, right? Let's take question 15. Let's take question 15. Derivative of x squared cos x. We have something like this. F of x equals x squared cos x. So we have this as u, this as b. So if we should then differentiate this, what we are going to have is cos x multiplied by du dx is what? 2x. Alright, because what we are using over here is the product rule, where we have v du dx plus u dv. Right, so this is x squared. This is cos x. So v, which is cos x, multiplied by the differential of x squared, which is what? 2x, and then plus u, which is x squared, multiplied by the differential of cos x, which is negative sine x, right? So the final answer is 2x cos x negative x squared sine x. And that's the answer to the question. And in this case, that is option. That's option A, right? Option A. Question 16 and 17, I have solved it. Check my channel page. I solved question 16. I also solved question 17, right? So now for question 18. For question 18, this is linked to implicit differentiation. For question 18, we have cos 2y equal to x squared. If you ask this kind of question, it's not difficult. Cos 2y equals to x squared. Just differentiate each side, right? But you can see that this side you are differentiating according to y. So what I'm going to do, I'm going to say let a be equal to 2y, right? dy over dA is going to be what? Sorry, dA over dy is going to be what? 2, right? And then let's say that the initial function was actually let's say y2 is equal to cos 2y, right? So if we differentiate this, what's that going to be? That you can write this as cos a, right? And that's going to be what? Negative sine a. So when we multiply this with this, we're going to have negative 2 sine 2y. Just differentiate it normally in your own understanding. Just like if you should differentiate cos 2x, you will get negative 2 sine 2x. It's the same thing, right? In this case, negative 2 sine 2y. So negative 2 sine 2y. Then since we have differentiated according to y, you attach dy dx and then differentiate x squared is going to be what? 2x. So divide through by negative 2 sine 2y, right? So this cancels this, and then we have that dy over dx. These two can cancel out these two, right? And that's going to be what? Negative x over sine 2y, right? Negative x over sine 2y, which corresponds to option A. Okay, next question. Negative 2 plus x over x squared. That's the function given. Negative 2 plus x over x squared. So if you are to get this, you employ what? Quotient rule, right? That says that dy dx is equal to v du dx minus u dv dx all over what? V squared. Right? So what is v? It's going to be x squared. Right? And then if you differentiate u, differential of negative 2 is 0, differential of positive x is 1, and then negative u, which is negative 2 plus x multiplied by the differential of v, which is what? 2x, and then all over v squared, that's x squared to the power 2, which is what? X4. So that's x squared minus 2x into negative 2 plus x all over x4. And that will be x squared negative 2x times negative 2 is what? Positive 4x. And negative 2x times positive, that's negative 2x squared all over what? X4. If you divide through by x4 in each case, you have x squared over x4 plus 4x over x4 minus 2x squared over x4, which is 1 over x squared plus 4 over x cubed negative 2 over x squared. Right? In this case, you can see that it was even factorized. It factored out x squared. Factored out x squared because x squared is common to all, right? So we can say 1 over x squared into 4 over x, right? Minus 2. Because if you should differentiate this, what you're having is x squared. That's what you're having is 2x. Okay. So moving to others. In case of question 21, this question is on parametric differentiation. And based on what I explained earlier, you should be able to get it. They're giving that y is equal to 6 cos t and that x is equal to 2e to the power t. Right? So what are we going to have here? dy dt is what? 6 times the derivative of cos t. If you differentiate cos t, what is it? Is negative sine t. So that's negative 6 sine t. Right? And then remember that if you are solving parametric equations, what you are solving is dy dx is equal to what? Dy over dt times dt over dx. Please take notes. Then if you should get dx dt, get the x dt, that's dx over dt will be 2 times the differential of e to the power t. And you should know that if you differentiate an exponent, it's still the same, right? It's still the same thing. Except if maybe it was e to the power 2t, then you now have to use chain rule to now ahead because there are two functions involved. Now in case of e to the power t, e to the power x is still what? E to the power t. That's 2e to the power t because 2 is a constant, right? So what we then do is that since the x over dt is equal to 2e to the power t, that means well, dt over dx now will be what? The inverse of this, right? That will be 1 over 2e to the power t. So we multiply these two values. Once we multiply them, that's the answer. So that's negative sine t multiplied by what? 1 over 2e to the power t. So 2 into itself 1, 2 into this, that's 3. And that's negative 3 sine t. Right? Negative 3 sine t. And then if you look at the options you have, it says find dy dx at t equal to 0. I see in the way it was now put. So we've gotten the value of the y dx. So all we simply need to do is to substitute anywhere we have t, we substitute 0. That will be minus 3 sine 0. And what is sine 0? I've said it earlier. Sine 0 is 0. So at the end of the day, the answer is what? Is 0. Do you get? And then if you've watched my videos, it's very important. You know the questions on application of differentiation. Right? Application of differentiation. Where I talked of, if you've not watched the full course, 8 videos on my channel based on application of differentiation, how to get equation of tangents, equation of normal, point of inflection, right? Relative maximum and minimum, just like this question now. This question now is based on that. Is based on that. Question 38. I explained how to calculate relative maximum and relative minimum. Let's solve this one. In this case now, I think I even saw this in my video, right? If you watch it. So if you have to get the relative maximum, right? If you have to get the relative maximum, you get the derivative of the function. Because the point here is that if you have a function, it has a maximum point where the first derivative is equal to 0. So if you should differentiate this, what are you going to have? 2x cubed minus 3x squared plus 1. If you differentiate it, 3 comes down, right? So it becomes 6x squared minus 6x. And differential of a constant is what? 0. So what happens next? 6x into what? X minus 1. You factor it out and equate the first derivative. Please take notes. Once the question comes up to you, what is the relative maximum? What is the relative? The first thing you do, you get the first derivative. We've gotten it as 6x squared minus, then you equate it to 0. You see that when we now equated to 0, what did we have? What did we have? That if we equate 6x to 0 and then x negative 1 to 0, we have that x is equal to 0, x equal to 1. Right? So the question now is, which one is now giving the maximum or minimum? That's where the question comes. Because in the exam now, they may decide to say what's the relative minimum. So how will you know? If you've watched that video, what we discussed is that you differentiate the function again. That's differentiate the first derivative to get the second derivative. And the second derivative, you differentiate 6x squared, is going to be what? 12x and then minus 6. Right? So you substitute each of these values you got from equating the first derivative to 0. You substitute 0, what are you getting? Minus 6. So if you substitute 1 into this, what are you getting? 12 into 1 minus 6, which is 6. 1 gave a positive result, right? Plus 6. Why 0 gave a negative result? The one that gives the negative result is what will give you the what? The maximum point. The one that gives the positive result is what gives you the minimum point. That's why if you watch that video, we said that second derivative is what? If the second derivative is less than 0, that means there is a maximum. But if second derivative is greater than 0, there is a minimum. So in the exam, if you are asked what is the relative maximum, what you will use to calculate is the one that led to a negative answer. In this case, minus 6, and that is what? 0. So after this now, you've now known the one that will give you a maximum. So you simply substitute this 0 into the original function. So if you substitute 0 into this, 2 into 0 to the power 3 minus 3 into 0 to the power 2 plus 1, right? And that's going to be 1. And it's this point over here. Because at x equal to 0, what was the output? The output was what? 1. Don't make the mistake of choosing this. This is wrong. You are trying to say x is 1 and y is 0. This is wrong. Is at x equal to 0. So, if you were now asked what is the relative minimum in the exam, what will be your answer? You use the one that led to a positive result, right? Which is x equal to 1. So if you substitute 1 into the function, are you following? If you substitute 1 into the function, what are you having? If you substitute 1 into this function, what you have is 2 into 1 to the power 3 minus 3 into 1 squared plus 1. And that's 2 minus 3 plus 1, which is what? 0. So you can see that the minimum point is 1, 0. Are you following? So you must be careful so that you don't mix it up. Right? So if you've watched that series of theoretical application of differentiation, I also explained how do you determine the set of values for which a function increases or decreases, and it's very simple. In this case, now this was the question I solved in that series. In this case, question 39. All you simply need to do here is to get the first derivative, and if they are asking you for the values for which it is increasing, it should be greater than 0. That is 6x squared minus 6x greater than 0. If you are asked what is the set of values for which is decreasing, this is the inequality you solve. 6x squared minus 6x less than 0. And you get it. That's differentiating the function. Okay. So I want to go through some questions because I've already created the video and I don't want much time to go. So I'm going to ask a poll right now, and please, I want you to participate actively. Right, a question now on application of differentiation. Right, and it goes this way. I will type it and then you see right now. Coming up, be patient. Okay, it's coming up soon. Equation of tangent at x equals to 1. The first option, we have 7y a poll is coming up. Please be patient a bit. So please, I just put up a poll and I want you to respond. I want you guys to respond. It's a question on determining equation of tangent. Right? The question on determining equation of tangent. To find the equation of tangent to the curve 2x to the power 3 let me copy this. Okay. Hi. So please, the question is to determine the equation of normal, not tangent. Right? So please put in your answers to the poll I just posted. To get equation of normal, we equal 2x to the power 3 minus x squared plus 3x plus 1. Y equals to 2x to the power 3 minus x squared plus 3x plus 1 at x equal to 1. At x equal to 1. It's pulling your answers. One is responding. So to get the equation of the normal, you first of all differentiate it. And if you differentiate it, that will be 6x squared negative 2x plus 3. And then this is the gradient. Right? And then you substitute x equal to 1. And that will be 6 into 1 minus 2 into 1 plus 3. And that is what? 7. So 6 minus 2 is 4. 4 plus 3 is 7. And if you watched my videos, you'll know that the product of the equation of the tangent and the normal, that's the gradient of normal and tangent, is equal to minus 1. And we've gotten the gradient of the tangent, right, as 7. That's the gradient of the normal will be negative 1 over 7. And then using the general form equation that says that m is equal to y minus yo over x minus x2. We've gotten the x2 as 1, but what's the yo is? Directly substitute it into the y function. And what's that going to be? 2 into 1 to the power 3 minus 1 squared plus 3 into 1 plus 1. And that's 2 minus 1 plus 3 plus 1, right? Which is 5. So that means yo is 5. So negative 1 over 7 will be equal to y minus 5 over x over x minus 1. And with that, have cross multiply. That will be negative 1 into x negative 1 is equal to 7 into y minus 5. And that will be negative x plus 1 is equal to 7y minus 35. And that will be 7y is equal to negative x plus 1 plus 35, right, which is 7y equal to negative x plus 36, which is 7y plus x. So this crosses over, then negative 36 equal to 0. And that's the equation of the normal to the curve. So that's it for differentiation. Watch the videos, practice, and I believe you do, guys. Okay, then in the case of integration, we are done, almost done. The last thing now is integration. So in the case of integration, you should know the basics. And it's the fact that if you have a function, and then you have to, and it's in the form x to the power n, right? If you have to integrate it, it's going to be what? X to the power n plus 1 over n plus 1 dx, right? So in the case of x squared, what's it going to be? The integral of x squared dx is going to be x to the power 2 plus 1 over 2 plus 1, which is x to the power 3 by 3, and then don't forget to add a plus c as a constant, right? And then moving upwards, according to the questions we have here, let me take some more questions. Right, you should know all the principles there. So in the case of this question, question 22, it says integral of e to the power x all over e to the power x plus 1 dx. In that case, what we have is understanding that if you are given an integral and then the denominator is the differential of the numerator is the differential of the denominator, then it's simply the lane of f of x plus c. Right, so in the case of e to the power x, over e to the x plus 1 dx. What I'm going to do here is let e of x plus 1, right, be equal to u. And if you should differentiate e of x plus 1, you differentiate e of x, it will still be e of x. And if you differentiate plus 1 is what? 0. So if you differentiate this function is equivalent to what? To the numerator. If you differentiate the denominator, you're getting, so it's simply what? The ln of x squared plus 1 plus c. Right? Just like if you are given this. If you are given something like this, let's say 2x over x squared dx in the exam, it's simply what? Ln x squared plus c, because if you should differentiate x squared, you are going to get what? 2x. Are you following? So that is why it is that way, right? And then evaluating definite integrals. But before we go into that, let's take this question 24 on this past question set. Integral of 6x over x squared plus 1 dx. So what I'm going to have here is let u be what? X squared plus 1. And you can see that the derivative of x squared plus 1 is what? 2x. But what you have here is what? 3x. So don't quickly say, we can't use that method. Because in integration, we have a law that says that if you have k of f of x dx is equal to what? K integral of f of x dx. So it's possible to factor out what you have in terms of 2x, right? So you can rewrite this as 3 times 2x, that's to suit the differential of the denominator, all over x squared plus 1 dx. So if we move 3 over, that will be 3 integral or 2x over x squared plus 1 dx. And then with this, we now have the right to say that, okay, this is clear, because if we differentiate this, we are getting the numerator. So that's 3 ln x squared plus 1 plus c. Sometimes it's put in absolute, because know that ln doesn't accept negative values, right? Okay, more questions. So let's take question 28 connected to what we are discussing. The integral from 1 to 3. The integral of 1 to 3 of dx over 2x minus 1. If you ask this kind of question, you observe it, right? Because you know that if you should differentiate 2x plus 1, what I'm going to get is 2. Are you feeling? But and numerator, what you're having is 1. So how do you now make it suit what you have? That means you're going to divide 1 by what? By 2, so that it will match. So you can write this as half 2 all over what? 2x minus 1 dx. Because half of 2 is what? It's still going to give you that 1 that was here, right? You're just trying to achieve something, because with this now, it right, it agrees with the fact that differential of the denominator, which is 2x minus 1, is equal to the numerator. So that's half ln 2x minus 1 plus c. So the question said from 3 to what? From 1 to 3 is equal to what? Ln k. Find the value of k. So to evaluate such definite integrals, what you do is to substitute each value of what? Each value. So in the case of x equal to 3, anywhere you have x, substitute 3, that will be half ln 2 times 3 minus 1. And then you now subtract when you now substitute 1 into it, right? So you are finding the difference between the two limits when they are substituted. That's half minus half ln. When 1 is now substituted, that's 2 into 1 minus 1. And that's going to be what? Half ln 2 times 3 is 6. 6 minus 1 is what? 5. Minus half ln. 2 times 1 is 2. 2 minus 1 is what? 1. So if we factor out, what we're going to have is half ln 5 minus ln 1. And you should know the logarithm rules. That says that log A minus log B is what? Log A over B. And that ln A minus ln B is what? Ln A over B. So we can have this as what? Half ln 5 over 1, right? Which is what? Half ln 5. So we can now move this half upwards using the index laws. You know this law that says that log A to the power n is equal to what? Or log x to the power n is equal to n log x. So we can move x up to become what? Ln 5 to the power half. And you know that 5 to the power half is the same thing as what? Ln root 5. Are you following? Ln root 5. So with this, it says if that integral is equal to ln k, right? This is the question, ln k. So that means ln k is equal to what? Ln 5. And if ln k is equal to ln 5, ln root 5, that means that k is what? Root 5. That's the answer to the question. So you should also be able to calculate definite integrals, right? If you ask for any definite integral, just differentiate, integrate the function, substitute the higher value, substitute the lower value, then subtract the lower value from the higher value, and then that's the value of the definite integral. Okay. And then the use substitution is also very crucial. The use substitution is also very crucial. As if maybe you are given something like this. Let's say you are given this question. 2x minus 3 to the power 7. Right? Dx. And you are asked to get the integral of this. You use the u substitution. What you say is let u be equal to 2x minus 3. Right? And then du over dx is equal to what? 2. And then you make dx the subject. Are you following? If you make dx the subject, that means that dx is equal to du over 2. Because if we cross multiply and then make dx the subject, we have that dx is du over 2, right? So we can now replace this integral as what? Integral of u to the power 7 du over 2. So we can move this 2 over to this and it becomes half integral of u7 du. And one thing about this u substitution is that after the substitution, there will be no x again. You would have eliminated every x. So if you now integrate this according to u, with respect to u, what are we going to have? U to the power 7 plus 1 all over 7 plus 1 and then plus c. So what's that going to be? Half u to the power 8 over 8 plus c, and that will be u to the power 8 over 16 plus c. You now recall that u is what? 2x minus 1, right? 2x minus 3. So that's 2x minus 3 to the power 8 over 16 plus c. So if you made the mistake, so don't make the mistake of, if you are asked in the exam, you now do 2x minus 3 to the power 7 plus 1 over 7 plus 1. That is wrong. Because there's another function that is acting here, which is 2x minus 3. So we have to use the u substitution. Do you understand? And you see that the final answer is what? 2x minus 3 to the power 8 over 16 plus c. Right? Okay. That's the solution to that. I'm just doing the best I can because I didn't really create any explicit video on integration. Just try my best to see what I can do as concerns that. And then from the other questions I can see here, question 26. Question 26 is another application of u substitution. It says find the antiderivative of the function 4x sine 2x squared plus 5. Right? Question says y equal to, that's 4x sine 2x squared plus 5. 4x sine 2x squared plus 5. So when you are given a problem, you ask for the antiderivative, which is equivalent to the integral of 4x sine 2x squared plus 5 dx. We are given this, look at the terms carefully and see whether there is any relationship. If one part leads to the differential of the other, you can make a substitution there. And now you notice carefully that if you differentiate 2x squared, you're going to get 4x. So you can make a substitution. You can say let u be equal to what? 2x squared plus 5, right? And then du over dx is equal to what? 4x. So if you now make the x, which is over here, the subject, you will now get that dx is equal to du over 4x. So that when you now replace the x with du over 4x, this 4x cancels out. Do you understand? So you will now be having 4x times sine 2x squared plus 5 multiplied by du over 4x. This cancels this, right? And then remember that we said let u be 2x squared plus 5. So this is same as what? Sine u du. Are you seeing how we simplified it? And then if you integrate sine, it's going to give you negative cos. Very important. It's going to give you negative cos u plus c. Are you following? Negative cos u plus c. So at the end of the day, you are ending up with negative cos u. And then you now recall that the value of u is what? 2x squared plus 5. Right? That will be negative cos 2x squared plus 5 plus c. And that's it. So by looking at the terms, look at the terms given to you and see whether one part is the differential of the other. So that by the time we now make the x the subject, it will now cancel it out. Are you see, making the job easier? Are you following? Okay. Yeah. And then this introduces us to, let me take question 23. Question 23 is on trig substitution. And it's possible that they could ask it because it's not that complex. The substitution is not that complex. If you just know the principle behind it, you'll get it accurately. Okay, so we have the integral of dx over square root of 4 minus x squared dx. Okay, we have already put the dx over there, so there's no need again. So what we use over here is the trig substitution, right? And we'll say let x be equal to a sine theta, right? And in this case, a is 2, right? I don't know if I'm explaining this well because there's no time to explain it in detail from scratch. So in this case, say let x be equal to a sine theta, kind of like a substitution. And there's a general integral that gives integral for the square root of a squared minus x squared. Please pay close attention in case if they just ask something in this form. You understand? So that I know the general rule, right? So in this case, a squared minus s. So you can see that in this case, a is what? A is 2 because 2 squared is going to give you 4. So taking the substitution of x equal to a sine theta, in this case, x will be equal to what? 2 sine theta. And if you are taking the substitution of x equal to a sine theta, you have to solve it. That you get value of dx d theta. If you differentiate a sine theta, you know a is a constant, right? It's going to give you what? A times the derivative of sine theta, which is cos theta. That's a cos theta. And your goal is what? Dx. So you can cross multiply. And you can see that dx is equal to a cos theta d theta. Now pay close attention. In this case, now we have 4 minus s squared and a is 2, right? So dx will be equal to 2 cos theta d theta. And in the case of 4 minus s squared, we'll now replace it as what? Square root of 4 minus 2 sine theta. Remember, we are squaring it. And then that's going to be integral of dx over square root of 4 minus 4 sine squared theta. And you can see that if we now factorize the denominator, we have square root of 4 into 1 minus sine squared theta, right? Which leads us to square root of 4. Then you should know the identity that says that sine squared theta plus cos squared theta is what? 1. Which implies that 1 minus sine squared theta is what? Cos squared theta. Are you following? And then with this we have integral of dx all over 2 cos theta. And then you now remember we said that dx is equal to what? 2 cos theta d theta. So we can replace the dx with 2 cos theta d theta. That's over 2 cos theta. This cancels this. And what we have is d theta, 1 d theta. And if you differentiate 1 d theta with respect to theta, what I'm going to have is what? Theta plus c. Just like if you differentiate 1 dx is what? X to the power of 0 plus 1 over 0 plus 1. In this case, is theta raised to the power of 0 plus 1 over 0 plus 1. And then theta plus c. So what is theta from all we've been saying since? Remember we said that x is equal to 2 sine theta. So if we divide through by 2, that means that sine theta is equal to x over 2, which implies that theta is equal to the sine inverse of what? X over 2. So the answer to this integral is sine inverse of x over 2 plus c. So in general, if you asked in the exam any integral in this form, square root of a squared minus x squared dx, it is simply the sine inverse of x over a plus c. Take notes. So if in exam you are asked this 1 over square root of 16 minus x squared dx, it's simply what? The sine inverse of x over what? Remember, a squared minus s squared. So if you express 16 as a squared, what you have is 4 squared minus x squared. That is what? Sine inverse of x over 4 plus c. Right? If it's the case of 1 over square root of 25 minus s squared, it's going to be sine inverse of x over 5 plus c. If it's the case of 1 over square root of 6 minus x squared, it's going to be sine inverse of x all over root 6 plus c, because root 6 times root 6 is what? Is 6. Do you understand? Okay. And then the question here, question 25, then application of partial fractions. Partial fractions integral, question 25. And in order to solve such integrals, studying what you have here, we are given integral of 1 over x squared minus 1, right, dx. And it's the same thing as integral of 1 over x minus 1 into x plus 1, right? So using partial fractions, we can say that 1 over x minus 1 into x plus 1 is equal to a over x minus 1 plus b over x plus 1, right? So with that, we can use cover up method, equate each component to 0, x minus 1 equal to 0, x plus 1 equal to 0, I have x equal to 1, x equal to minus 1. So in the case of x equal to 1, which is from x minus 1, substitute 1 into the function and then dispose this off. So if we do that, if you substitute 1 into this, all I'm going to have is 1 all over, we are disposing x minus 1, no? That's 1 plus 1. We are substituting this. We equated this component to 0. Hope you are not confused. We equated this component to 0 and the output is what? 1. Right? And then we now substitute that 1 into the entire function without substituting it into the work cost. Do you understand? So substituting it, we have 1 plus 1, which is what? 1 over 2. So that tells us that A is 1 over 2. So we can write it as 1 over 2 into x minus 1 and then plus B. How do we get B? When we equate x plus 1 to 0, we have minus 1. And then if you substitute minus 1 into this exempting x plus 1, what do we have? 1 all over, substituting it in x minus 1, we have minus 1 minus 1, which is what? Minus 1 over 2 x plus 1. So with this, our final result is 1 over 2 into x minus 1 minus 1 over 2 into x plus 1. You can see we can factorize it, right? As half into 1 over x minus 1 minus 1 over x plus 1. So with this now, you can differentiate it. You can integrate, sorry. If you should integrate 1 over x minus 1, what are you going to have? Ln of x minus 1. Because if you differentiate x minus 1, you're going to have 1, which is equal to the numerator, right? So this is equivalent to half of ln x minus 1, right? Minus, if you should differentiate x plus 1, you still get 1 because differential of the constant is 0. So this is what? Ln x plus 1. Now using the law that says that ln A minus ln B is equal to ln A over B, what are we having? It's going to be what? Half ln x minus 1 all over x plus 1, right? Half ln x minus 1, this is, and then plus c, that's the answer. But if you now want to move the half up, what we have is in x minus 1 over x plus 1, and then you know that's the same thing as square root of x minus 1 and then plus c. Are you following? So that's it. It's that easy. Okay, and then you should also know integration by parts. Integration by parts is also important, and it's the fact that v du is equal to uv minus u dv. In the case of this integral, where we have x e to the power 2x is a product, right? But that's not a license to the fact that if you just see two products, you start using this. Just like the case where we solve antiderivative of 4x, 4x into, what is that question? 4x sine 2x squared plus 5. If you see a relationship, if you see that one leads to the differential of the other, hey, you can use the u substitution. But in this case, there is nothing that links it up. There is no differential that would save us here. So we can now label any way we want it. And label this as v, label this as what? U. Right? So, as du, sorry. So what is u? Remember, this is what? This is du now, right? So in order to get u, you have to integrate e to the power 2x. And to integrate e to the power 2x, let's do that over here. We'll say u equals to 2x, and that du over dx is what? Is equal to 2, right? That means that dx is equal to du over 2. So if we now replace it in this integral, what we have is half into e to power u, what? Du, which is half eu, because if you integrate e to power u, it's still the same thing, plus c, which is half e to the power 2x. So we can write this as v, which is u, we've gotten u, which is the antiderivative of du, right, as half e to the power 2x, and then multiplied by what? X, right? And then minus the integral of u, which we said is half e to the power 2x, multiplied by dv, which is what? 1. I following. So we've now made, the job is now easier. We have half e 2x multiplied by x minus half integral of And now if we should integrate e to the power 2x, I've already done it before, right? We should differentiate e to the power 2x dx. What we have is half e to the power 2x multiplied by x multiplied by half into, remember we did it before, and we got half e to the power 2x, right? So that's half into half e to the power what? 2x, and then plus c. That's going to be half e to the power 2x multiplied by x minus 1 over 4 e to the power 2x plus c, and that's integration by parts. That's the final result. That corresponds to which of them? That's x all over, that's option C, right? Half x e to the power 2x minus 1 over 4 e to the power 2x plus c, right? That's it. Okay. What else? So that's it for integral calculations. You want to practice with other questions. And then also the application of integration. That's the last part of this live session, right? Application of integration. This is in case if they ask it. If you're asked to determine, there are two possible things. To determine the area between a curve and line. In the case of, you look at question 37, to find the area between the curve y equal to negative x squared plus 5 and the line y equal to 6. Let's say you ask this in the exam. Y equal to negative x squared plus 5x, and you were asked what is the area bounded. It's not difficult, right? So what do? This is just like a curve. I don't want to. This is how the curve looks like, because this is a negative, right? And then the line y equals to 6. Let's say y equals to 6 is here. So the question is, what's the area between this? So what you simply do here is what? You equate the two, because this is y, this is y. They're going to meet at two distinct points, right? So what we're going to have is negative x squared plus 5 is equal to what? 6, right? So what we're going to have is negative x squared plus 5x, and then this 6 can move over to become what? Minus 6. Then you can multiply through by minus. Are you getting me? You now have x squared negative 5x plus 6 equal to what? 0. And then if you should solve this, to be x squared minus 2x minus 3x plus 6 equal to 0. That'll be x into x minus 2 minus 3 into x minus 2 equal to 0. And that's x equal to 3 or 2. Right? And that corresponds to the fact that this point is likely to be what? 2. This point is likely to be what? 3. So these are the two endpoints. So this links us to definite integrals. That means you are going to integrate the function from 2 to 3 of what? Negative x squared plus 5x minus 6. That is what you are going to do, the x. Do you understand? So when you are given two equations, take this to the back, right? Solve the equation to know what the endpoints are. Do you understand? And then solve the integral. So if we should integrate this function, integral of negative x squared, and then we have plus 5x minus 6. What are you then going to have? It's going to be negative x to the power 2 plus 1 over 2 plus 1, right? Plus 5x to the power 1 plus 1 over 1 plus 1 minus 6x plus c. You get? So we're going to have is negative x to the power 3 over 3 plus 5x squared over 2 minus 6x plus c. And then what you now do is to substitute these n values. You understand? Substitute 3, substitute 2. Starting with substituting 3, we have minus 3 to the power 3 over 3 plus 5 into 3 squared over 2 minus 6 into 3. And this is going to be minus 9, right? This is going to be 5 times 9 is 45. That's 45 over 2 minus 6 times 3 is 18. And that's negative 27 plus 45 over 2. And then we can write this as negative 54 over 2 plus 45 over 2, which is negative 9. I guess negative 9 over 2, right? And then you now substitute what? 2 into the function. If you substitute 2 into this, what are you going to have? That's into this integral. You're going to have negative 2 to the power 3 plus 3 plus 5 into 2 squared over 2 minus 6 into 2. You get? And what's that going to be? It's going to be negative 8 over 3 plus what? 5 times 4, 20. 20 divided by 2 is what? That's 10. Negative 6 times 2 is negative 12, right? And that's negative 8 over 3 minus 2, right? Because 10 minus 12 is 2. And then if we simplify this, it's negative 8 over 3 minus 6 over 3, which is what? Minus 14 over 3. So what we now do is to subtract these values. That's minus 9 over 2 minus 14 over 3. Are you following? And then we take the LCM as 6. This becomes plus, right? So 6 divided by 2, 3. That's times negative 9. That's negative 27 plus. 6 divided by 3 is what? 2. 2 times 4. 2 times 14 is what? 28. Minus 27 plus 28 is what? 1. That's 1 over 6. I do get. So that's option C. So it's just for you to master it. If you've not practiced it, it may seem challenging. But all you need to do is, once it's given to you this way, equate the two, because it says y is equal to this, y is also equal to this. So they're going to meet at a point. So then equate them together, solve the equation to get the n values, and then integrate from the lower to the higher value. And then what happens? You then integrate, just like what we did here, right? You now integrate the function of when you've shifted this to the what? To the back, because you know that this y equal to 6 is the lower function, right? So you move this to the left and then solve for the integral. So let's take this question based on this stuff, this area of a thing. So let's say you are given y equal to x squared and y equal to 4. If you're asked, so I want you to attempt this. If you ask what's the area between y equal to x squared and y equal to 4, and what the x-axis, the area bounded by the curve y equal to x squared, y equal to 4, and the x-axis. You know that the curve y equal to x squared is going to be a minimum, right? And y equal to 4 is going to be above it, right? So if y equal to 4 is above it, what we're going to have is that x squared is equal to what? 4, right? So we move this x squared over to it, because this is the higher function. Even though you mix it up, we are going to have a negative value, right? Right? Even though you mix it up, we're going to have a negative value. But the best thing is, what happens from the higher to the lower? In the other case, you can notice that we subtracted the other way around, because in the case of negative x squared plus 5 is a maximum function, right? So the line was lower, but in this case the line is higher. So that is why it will take the lead. So it will be 4 minus x squared. This x squared moves over to this side, equal to what? 0. You now solve this equation. If you should solve 4 minus x squared equal to 0, that means that 4 is equal to x squared. And if 4 is equal to x squared, what does that mean? X is equal to plus or minus 2. So what do? You solve the integral from minus 2 to 2 of what? 4 minus x squared dx. It's a very possible question. So with this, now if you solve it, if you integrate this, that will be 4x minus x to the power 2 plus 1 over 2 plus 1 plus c, right? And that's going to be 4x minus x to the power 3 over 3 plus c. And then you substitute each of these values. If you substitute 2 into the function, what will you have? It will be 8 minus, if you substitute 2 here, that will be 8 minus 8 over 3, which is going to be 24 over 3 minus 8 over 3, which is what? 16 over 3. Then you substitute minus 2. If you substitute minus 2, what we have is 4 into minus 2 minus 2 to the power 3 over 3, which is minus 8 minus 8 over 3, which is minus 8 plus 8 over 3. And then if we should simplify this, we have minus 24 over 3 plus 8 over 3, which is negative 16 over 3. So we now subtract the values. So what will be the final area? 16 over 3 minus 16 over 3, which will be 16 over 3 plus 16 over 3, which is 32 over 3. And that is the area bounded. Right? That is the area bounded. So please be able to do this, because that's most likely to check the material, because you saw that questions there in the last page. And then lastly, that's all for Maths 103. Done my best. Volume of solid of revolution. Right? If you ask for volume of solid of revolution, it's a simple thing. It could be rotation about the x-axis or rotation about the y-axis. Right? You have a line, and then there's a smaller circle, and then it becomes larger, right? So what's the volume of the solid generated? If it is rotated about the y-axis, or if it's rotated about the x-axis, you ensure that if it's for the x-axis, you are going to have the integral of pi from a to b of what? Y squared dx, because y will surely be in terms of x, right? Just like if you have y equal to 3x plus, do you understand? To be in terms of x. Then if it's about the y-axis, to now make it to be in terms of y, it will be the integral from a to b of pi x squared dy. Because if it's in terms of y, if it's given to you as y, that means as x, that means the output is, you're going to have y. That's like if you have y equal to 3x. If x is equal to y over 3, you can see that the value of x is expressed in terms of y. Are you following? And then this is the basic method. This is the basic method, and is called the last of called this method, right? So let's take a question. Let's take a question. So if you are asked for the volume of solid, let's say I ask this question. It says find the volume of the solid generated when the region bounded by y equal to 2x, x equal to 2, x equal to 4, and the x-axis is revolved through 2 pi radians, which is equivalent to 1 complete revolution, 360 degrees. So what do? These 2 points are your A and B. This is what we are looking at. Are you following? So that is what? From what? 2, which is the lower, to what? 4 of pi y squared dx. And what is y in this case? 2x, right? So that will be integral of 4. You can bring the pi backwards because it's a constant, right? And then since y is 2x, if you square 2x, what are you going to have? 4x squared, right? So you now do the integration. If you should integrate this, what are you going to have? It will be 4x to the power 2 plus 1 over 2 plus 1 plus c, which is 4x to the power 3 over 3 plus c. And then you attach the pi there. So you substitute each limit. That's, if you substitute 4 into this, what will be the output? That will be pi into 4 times 4 to the power 3 over 3, right?